Welcome back to the Microsoft Excel training series. In the previous phase, we built a strong foundation by learning how to navigate the Excel interface, understand rows, columns, and cell references, and enter and format data effectively. We also explored how formulas work and used essential functions like sum, average, min, and max to perform basic calculations. These skills introduced you to how Excel processes data and performs automated computations. In this new phase, we are taking the next step by learning how Excel can make logical decisions within your spreadsheets. You will be introduced to essential logical functions that allow Excel to evaluate conditions and return different results depending on the outcome. Functions like if will allow you to automatically classify data, test conditions, and control calculations based on specific rules. By the end of this phase, you will understand how logical formulas help transform ordinary spreadsheets into smart worksheets that can analyze information and respond dynamically to your data. Let's begin exploring essential logical functions in Microsoft Excel. So, we will start with the if function. The if function is one of the most fundamental and widely used logical functions in Microsoft Excel. At its core, the if function follows a simple structure. Excel checks a logical test, and if that test is true, it returns one value. If the test is false, it returns an alternative value. This ability to introduce decision-making into your spreadsheet transforms Excel from a simple calculation tool into a dynamic system that can respond intelligently to data. The if function is especially useful for categorizing data, performing conditional calculations, and building rules that automate repetitive decision processes. It serves as the foundation for more advanced logical operations in Excel. In this worksheet, the if function is used to determine whether a student has passed or failed based on their score. Excel begins by evaluating the condition inside the formula, which checks whether the score in cell A2 is greater than or equal to a specific threshold. In this case, 50. If the condition is true, meaning the student meets or exceeds the required score, Excel returns the result pass. If the condition is false, Excel returns fail. What makes this powerful is that Excel applies this logic instantly and consistently across multiple rows when the formula is copied. Instead of manually reviewing each score, Excel performs the evaluation automatically, ensuring accuracy and saving time. This simple example demonstrates how the if function can be used to create clear, rule-based outcomes within your data. Before we go further, it is important we consider other variations of the if function. Nested if and IFS are functions used in Microsoft Excel to evaluate multiple conditions and return different results depending on which condition is satisfied. A nested if formula works by placing one if function inside another. Excel evaluates the first condition, and if it is not satisfied, it continues evaluating the next if statement. This structure can handle multiple decision paths, but may become difficult to read when many conditions are involved. The ifs function was introduced as a simpler alternative. Instead of nesting multiple if statements, IFS allows several logical tests to be listed in sequence. Excel evaluates each condition from left to right and returns the result associated with the first condition that evaluates to true. In this worksheet, Excel is used to convert numeric scores into letter grades. The first formula uses a nested if structure. Excel checks whether the score is greater than or equal to 85 and returns grade A if that condition is not satisfied. Excel evaluates the next if statement to check whether the score is greater than or equal to 70 and returns grade B if that condition also fails. Excel continues evaluating the next level of the nested formula until it reaches the final result. While this method works correctly, the formula becomes longer and more difficult to read as more conditions are added. The second formula demonstrates the ifs function performing the same task. Instead of nesting multiple if statements, the conditions are listed sequentially inside the IFS function. Excel checks each condition from left to right and returns the first matching result. Because the formula structure is simpler and easier to interpret, ifs is often preferred when working with multiple decision rules in modern versions of Excel. Logical operators form the backbone of logical expressions and are commonly used inside functions like if, and and OR. Some of the most frequently used logical operators include greater than, less than, equal to, not equal to, greater than or equal to, and less than or equal to. Each of these operators is used to compare values and determine whether a condition is true or false. For example, Excel can evaluate whether one number is greater than another, whether two values are equal, or whether a value falls within a specific range. Understanding how these operators work is critical because they define the rules that Excel uses to make decisions. In this example, logical operators are used within an if function to evaluate a condition. Excel examines the value in a specific cell and compares it to a defined threshold using an operator such as greater than or equal to. For instance, Excel may check whether a score is greater than or equal to 50. If the condition evaluates to true, Excel returns a result such as pass. If the condition evaluates to false, it returns below threshold, and if it is exactly 50, it returns borderline. What's important to notice is how the operator defines the rule. Changing the operator from greater than to less than, or from equal to not equal to, completely changes how Excel evaluates the data. This means that by simply adjusting the logical operator, you can control how Excel interprets and responds to your dataset. Now, let us take our journey a step further. The AND function allows multiple logical conditions to be evaluated at the same time in Microsoft Excel instead of testing only one condition, and lets Excel check several requirements simultaneously. The function returns true only when every condition inside the AND statement is satisfied. If even one condition fails, the result becomes false. When the AND function is combined with the if function, it enables strict logical evaluation. In this worksheet, we have two columns, score and attendance. The formula entered in cell C2 is if and A to greater than 50 and B to greater than 75, then return pass. Otherwise, return fail. Excel first evaluates the logical test inside the AND function. It checks whether the student's score is greater than 50 and whether their attendance is above 75%. Both conditions must be true at the same time. If both requirements are satisfied, Excel returns the result pass. However, if either the score or the attendance fails to meet the requirement, Excel returns the result fail. Now, on the other hand, the OR function is another logical function used in Microsoft Excel to evaluate multiple conditions. Unlike the AND function, which requires all conditions to be true, OR returns true when at least one condition is satisfied. When OR is combined with the if function, Excel becomes capable of making flexible logical decisions. If any of the specified conditions are true, Excel returns the designated result for tier UE. If all conditions fail, Excel returns the alternative result. In this example worksheet, the columns represent sales and performance rating. The formula in cell C2 checks to different conditions. Excel evaluates whether the sales amount exceeds 10,000 or whether the employee's performance rating is marked as excellent. If either of these conditions is satisfied, Excel awards a bonus. The employee does not need to meet both conditions because OR requires only one condition to be true. If sales do not exceed 10,000 and the performance rating is not excellent, Excel returns the result no bonus. This example illustrates how OR supports alternative qualification rules in decision-making models. The count and counter functions help analyze datasets by measuring how many entries exist within a range in Microsoft Excel. Count calculates the number of cells that contain numeric values only. It ignores text, blank cells, and other non-numeric content. Counter works differently. It counts every non-empty cell regardless of whether the content is a number, text, or another type of data. Together, these functions help determine the size and completeness of a dataset. In this worksheet, cells A1 through A6 contain a mixture of numbers and text values. The formula in cell A8 uses count to calculate how many cells contain numbers only. Excel scans the range and counts only the numeric entries. In cell A9, the formula counter counts all cells that contain any value, including text entries. Because text values are included in the count, the result from counter is typically larger than the result from count. This comparison helps illustrate how Count focuses only on numerical data while Counter measures the total number of populated cells, be it in numbers or texts, dates, or any other format. The Counter function in Microsoft Excel is designed to count how many cells satisfy a specific condition. It requires two arguments: the range to evaluate and the criteria that define the condition. Excel scans each cell within the specified range and checks whether the value matches the criteria. Every time a match occurs, Excel increases the count by 1. In this worksheet, the department column contains entries such as sales, human resources, and information technology. The formula count of A through O6 sales instructs Excel to count how many times the word sales appears within that range. Excel evaluates each cell in the department column and increases the count every time it finds the value sales. Once the scan is complete, Excel returns the total number of matching entries. This example demonstrates how COUNTIF can quickly summarize categorical data. Still on logical functions, the SUMIF function performs conditional addition in Microsoft Excel. It adds numbers only when specific conditions are satisfied. The function works using 3 arguments. The range identifies the cells that will be evaluated against the condition. The criteria define what condition must be met. The sum range specifies which values should be added when the condition is satisfied. In this example, column A lists different departments and column B displays their sales amounts. The formula SUMIF A through O6 sales B through B6 instructs Excel to add only the sales values associated with the sales department. Excel first evaluates the department column to locate rows where the value sales appears. For each matching row, Excel then adds the corresponding value from the sales amount column. The final result represents the total sales generated by the sales department alone. The average function calculates the mean of values that satisfy a specific condition in Microsoft Excel. Instead of averaging all numbers within a range, Excel filters the data first and then calculates the average of only the qualifying entries. In this worksheet, the region column lists geographic areas, while the revenue column displays sales values. The formula average A through A6 West B through B6 instructs Excel to calculate the average revenue only for the West region. Excel scans the region column to identify rows where the value West appears. For each matching row, Excel collects the corresponding revenue values. After gathering all relevant numbers, Excel calculates their mean and displays the result. This method allows analysts to calculate conditional averages quickly. Errors sometimes occur when formulas attempt operations that cannot be completed, such as dividing by 0 or referencing invalid data. The IFERROR function in Microsoft Excel provides a way to manage these situations gracefully. Instead of displaying technical error messages such as divide by 0, Excel can return a more meaningful message defined by the user. In this worksheet example, the formula attempts to divide the value in cell A by the value in cell B2. Because cell B2 contains 0, Excel would normally produce a divide by 0 error. However, the formula is wrapped inside the IFERROR function. This tells Excel to replace the error with the custom message not applicable. Instead of displaying an intimidating error code, the worksheet now provides a clear and user-friendly result. I bet it's been an interesting journey so far. In this phase of the training, we explored several essential logical and conditional functions in Microsoft Excel. You learned how to use the AND/OR function to evaluate multiple conditions. We also looked at how count, counter, and COUNTIF help measure and analyze datasets, and how SUMIF and average perform calculations based on specific criteria. You also discovered how IFERROR improves spreadsheet usability by handling formula errors gracefully. Together, these functions significantly expand Excel's analytical capabilities and prepare you to build smarter, more dynamic spreadsheets. In our next phase, we will take a deep dive into the lookup functions, the XLOOKUP, lookup, and lookup, and how they retrieve information efficiently from structured tables. You will understand their differences and specific uses. So, if you found this video helpful, don't forget to subscribe and follow the channel so you don't miss out on future lessons. There's a lot more to explore in Microsoft Excel, Make sure you turn on notifications so you're the first to know when it drops. Thanks for watching, and I'll see you in the next session. Bye for now.